Are we live? I think, yep, there's Twitch, and YouTube probably will follow in just a moment. Oh, this coffee was not so good. Come on, do the connecty thing. Connect. All right, I guess we're live. I think we're live. I hope we're live. All right. So, I was struggling a little bit visualizing exactly what's going on. And the problem was that I hadn't really been doing proper output visualization, which was kind of what I wanted to do, which was kind of the point. So, let's do that, right? So what do I want to visualize? So what I was imagining is, we want from the starting and end positions. So what are the options, right? From each point, there's like, okay, if we're taking one point at a time, just a start point where I'm start dragging, it's either going to be a corner point or a center point. And there's basically only one of those, right? The real problem comes in when we draw a diagonal line, right? If I draw a line between this circle and this circle, it doesn't tell me much about what kind of line I want to draw. So things get quite subtle, right? So at that point, we don't actually want to draw a line. At that point, we basically want to wait until the cursor maybe moves a little further until we start drawing the line. And that's kind of masked, that behavior we can mask by the fact that, so we can hide these, by the fact that we don't actually immediately show a hint line anyways, right? So if I skip this check here, right? We're going back. Now it should just immediately keep drawing the line. Yeah. So now I want to visualize the rest of this situation, right? So from the starting position, we have a distance to this corner, and this. So if we're, okay, so we have basically a weighted weighting between these four corners when we're in the central region, and when we're in a corner region, we have a weighting between these four central points. That's in case we're drawing a line that is not obviously the line that we started drawing. So instead of, if I don't think of it in terms of which point we're starting from, because there's 2 points on a line, but what kind of line we're drawing, maybe that will be a little bit more specific. So for example, it's gonna be either an edge line. Well, okay, so we have an edge line, we have a center line, we have horizontal or vertical, right? So I can express these as basically two crosses. And if I'm within the cell, there's two possible edge lines. Okay, so let's think about how we're visualizing this. So one of the things I want to visualize is, I want to visualize a line that is thicker or thinner. So I definitely want to give it a kind of styling, right? So we want to do something, we want to pass in some extra args, right? Yeah, we're going to do args.stroke or this, and args.width or that. And now, this will still draw perfectly fine, I imagine. Oop, or not, because I completely misspelled that immediately. That didn't take long. Let's hope some of you guys are going to join again. It was nice to have a few people in chat. Okay, and that line is being drawn not from here, not from here. The bug line here, right. So let's find the two closest edge lines, for example, right? And we can do this by adding and subtracting 0.5 on the vertical, right? So, so we have start RC. And then we're gonna do a rc.add scalar. We don't actually. We don't want to add scalar. Do we have a non-scalar add? Yes, we do have a vector add, right? So add start RC, and then we'll do let's do rows. So we do minus 0.5 C0 and positive 0.5. So that should give us that point above and below where we're drawing. So R gets smaller and R gets larger. And the thing is, it's using floor instead of round. So this is already rounding down. So if we do RC round on these, do we end up... Where do we end up? Let's find out. And this RC, I want to get rid of 293. This bit here. Two and 3. Okay. So let's just call these things something here. So we'll call that we call this, so this is an edge line, horizontal edge lines, right? So let's call it horizontal edge line up and horizontal edge line down, where we're adding 0.5. Right, and now we're going to do a debug line on each of these. Right, and we're just going to go, we're going to go back a little to the left. We're going to start from rc.add row 0 col -2 or -3 from this to +3. Right, so that's the positions, and now the arguments go here, and the arguments will be something like stroke, we're gonna make it blue. We'll make it something like that, and then stroke width 5, something like that, just so I can vary it. So I have everything in place and I can just move things around. All right, there we go. And we probably want to make this a bit thicker. And that's still a red arcs. Stroke width. Oh, okay. Yeah. Let's just... We're just going to preload them as these things. Yeah. And then we're going to do object.entries args dot for each key val set attribute key val. Yeah, I forgot we only create this thing once. Okay, now we've got the blue line there, and we'll create a second blue line on the other side. And this would be the HE down line. And we need to give them different IDs. Like this. So they're actually different lines. Okay. Okay, so that's interesting. Because we're always flooring, we don't actually want to subtract here. So if I do this, it's going to give me inconsistent behaviors, right? So the central area here will give me these two lines. Yeah, except those aren't really my options, right? So it's actually going to be 0 and 1 because of the RC round behavior being floor instead of round. Okay, so that gives me the two candidate horizontal lines. And let's do one kind of, because I think the edge versus center line behavior is the thing. The vertical versus horizontal isn't actually that hard. And now and now I want to determine which one of these two is more likely, right? And I don't want to say midpoint, but basically it's midpoint, right? Except, excuse me. Maybe we should be updating this on move. We aren't updating this on drag move. Wait a second. Yeah. Because we're only using the start input into consideration right now. Okay. So we have start RC, input RC. All right, and we can do let mid RC equals RC.mid. Right. So if we use mid RC instead of start RC, what does that look like? And we're going to just return from here. All right. And now we're just going to find the relative value between these two on the vertical, right? So that's basically the distance of our midpoint from either one of these. And we're looking at the row value right now. So mr.r, and if I do mid rc dot r minus math dot floor mid rc dot r, that should give us the fractional value within the cell, right? And that's basically it. That's our percentage. So 90 versus 0. Yeah. So net bias equals this. And then we're going to multiply this. So we'll do 1 plus 20 times 1 minus bias. And then here the same thing for just bias. So this tells us, okay, if we're drawing this, it firmly thinks that should be the line. If we're drawing this, that should be the line. Okay. And now we'll do the same thing for so this is horizontal edge. And now we'll do the same thing for center. Okay. So that's all of these. We're gonna hide these for now. Now we're gonna do more or less do the same thing. So horizontal center up and horizontal center down. And now we're going to we're going to round it first, I guess. And then we're going to add. And this inversion I'm encountering so many times now, so I'm starting to smell that there's some sort of reduction of code and optimization I can do. Right. Let's just draw the same thing and see what happens. Ooh, yeah, HC up. And HC down. That's what we just had. Oh yeah, of course, because now we've rounded it, now we actually need to move it back into position. So rounding is floor, just to keep things confusing. Ah, there's a pillow under my ass that's slipping all around. Oh, I hope one day I can fix my chair again. So wherever we are in the cell, we're rounding it to this edge. So we need this line and that line. So minus 0.5 and plus 0.5. Right? And we also want to draw a debug line at the midpoint. So we're going to do a debug line mid RC. And it's just going to be at mid RC. Mid RC, zero length. But it's going to be yellow? No. 0, 0, 0. And it's going to be quite fat. So half a cell in diameter, right? Yeah, perfect. So that's our center of the line. And that's going to determine... So you see, this doesn't actually make sense to me. This should be between this one, and this one. So it looks... so that the bias is really what's confused here. Except no, it's not. Yes, once it's here, it shouldn't be these two lines anymore, right? It gets floored to here. Yeah, okay, we need to add something before the rounding as well, and then afterwards again. So we need to round on both sides of the round here. It's so annoying that the round here is not a round, but a floor. So we're converting the floor basically to a rounding by doing this. We need to subtract 0.5, right? Nope, we need to add 0.5. Whoa. Yeah, the bias is wrong. One sec. This gives a fractional value. And we need to add 0 points. Need to add, I think, 0.5 to it. Because I think the bias here can be positive as well as negative. Right? Or maybe not. One second, my brain. I'm trying to think. 6.5, so that gets us 0.5. Now if I go to here, by 6.0, that gets us 0.0. We want a positive and a negative value here, I think. Yeah, okay, so the floor thingamajig here, we want to add 0.5, I think. No, subtract 0.5. I think we need to subtract 0.5 and then add it back in afterwards. Or the other way around. Alright, let's not just guess about this. So this value... So if I'm drawing this line, right? This value is something 0.5. But we want that to be actually a round number. So we're adding this, which basically pushes it to this line. Then we subtract this line. And then we need to add 0.5 back in. Actually, I think we need to subtract in here and then add it on the outside. Nope. One second. Sit back. 1 second. We want to shift the whole grid by 0.5. So we have to do it inside and outside. So we either have to shift it in here and here. And it shouldn't matter which way we're shifting it, right? If we're shifting it up or down, as long as we're shifting it in the same way. So it's all there, and now it's all there. Now it's all there, and then it goes to there. Okay. And if I bring this plus to the outside, then I would have to subtract. Anyway, this is fine. So this gets us the bias for that. So let's make that green. And then let's bring these back. So we have our edge lines and our corner lines. Sure, let's prefix everything. Like this. Prefix all the things. I'm gonna check the chats a bit because I don't trust Restream right now. Screwed me over earlier. I am live, right? Yeah, I am. I'm live. All right. Okay. So this is the confidence it has. Now this is really just looking at the central line. At the central point of the line. Is that good enough? Is that good enough? Like, is this it? Is like whatever the bias here is already the correct line, and then we'll just figure out vertical versus horizontal by the angle? Like, does this make sense to be an edge line? Yeah, I guess it does, right? And if we calculate end RC again, and which we did earlier, so if we do right, if we do this, we'll do it 1 unit length. Then we'll do this, start RC, end RC, and use this, and then the rest doesn't actually matter. So we'll only go up to 1 unit out. All right. Now it's obvious which... The thing what this gives us is it could switch from edge to corner lines, which I'm not too fond of. Although, as long as we're within the first line, I guess that's acceptable. So the idea is, if you go across and you haven't like locked in the first line yet and you shift up, it could shift the whole line up. Although we don't actually necessarily have to do that either, right? We could simply say, once we're hitting past that midpoint, that's when we pay attention to this line in the first place. So instead of using len here, so we're calculating the vector, right? But actually, I don't want to calculate it based on the full length. I want to calculate it. Sorry, 1 second. So so the vector is equals, we subtract. So the vector is this. Right. So that's the unit vector from, well, that's just the unit vector of the line. So if I want to now draw a line of length min, length of this, and the actual length, and we want this to be 0.5, so we want to add the start, and then we want to multiply it by math.min, the smaller of these two, wait. We know the length of the vector. The length of the vector is 0.5. It's the other way around. We always need to divide it by... Okay, it's this part actually that matters. So I'm barking up the wrong tree here. Sorry, I'm trying to do math in my head. Math of the minimum, no, the max of 0.5 and length. Whichever one is smaller, sorry, min. So if length is smaller than 0.5, we use length. If it's larger than 0.5, we don't use it. And then we calculate the midpoint based on that. And then once we go beyond 0.5, that's when we say, okay, it's locked in, right? Instead of 0.5, we'll do min dist. Yeah, exactly. So we can say, okay, the min distance would be 0.8, for example. And that's our tunable parameter. And that's basically at which point do we lock in the direction. And the distance is how far you've drawn. The other thing we could use is the minimum sort of confidence, or the maximum confidence, right? So whichever bias hits the highest. Now what we don't have is the relative bias between the center line and the edge line. And that should really be calculated by the distance of the midpoint from those. All right, so center edge bias. So we have R. So we have the midline R, which is the actual value where it is. The relative the closest center line, no, sorry, the closest edge line is the rounded, right? That should be the closest edge line. And the closest center line is rounded, is subtract 0.5, round, and then add 0.5. i.e. shifting the coordinate grid. So basically, if we're at 0.5, we'll subtract 0.5, it becomes 0. We round it to 0 and we add 0.5 back in. When we're at 1, we subtract 0.5, we're at 0.5. It rounds down, it rounds down or up. No, wait. If we're here, if we're slightly below it, it'll round down to, we subtract 0.5, it'll be here. No. If we're, one sec. If we're here, we subtract 0.5. If we're here, subtract 0.5 will be here. If we're here, we want it to round up to here. So if we're here, we want to subtract 0.5, round it to here, and then add 0.5. And if we're here, we subtract 0.5. It'll be below here, rounds to here, and then, okay. So we subtract and then add. Minus 0.5 plus 0.5. Okay. Slowly. And then we'll obviously get it to the nearest cell, whatever. Well, actually, we need to do that now. So that's the actual value. So now we need the distance from this value to this value. And I guess absolute distance is fine here. From, oops. I think that works. So right now the first bias is our edge line. So right now the highest value should be on the center line, or the inverse of the highest value. Now as we go towards the edge line, that will reach 0.5. Let's start here. So as we're here, that'll reach 0.5 and that'll reach 0. So these go from 0 to 0.5. Because our distance can only ever be 0 to 0.5. Okay. And they're basically just inverses of each other. So if you multiply these by 2, and that should give us, so the first value is how likely are we, or how far are we from being a center line. So that goes towards 0. And it flips over and it goes up again. And then how far are we from, and the other one would be near 1. And this one, the other one will be near 0. Okay, so we don't actually need to calculate both of these. So this gives us the center line to edge bias. Okay. And now we can maybe express that with opacity instead of thickness. So let CE bias equal this. And in the CE bias, 0 is edge line and 1 is, okay, so 0 equals edge, 1 equals center. Okay, and now let's turn that into RGB color thingies. I think the easiest way to do this is, so let HE color RGBA, excuse me. So 0, 0, 200, whatever. And then this will be our C bias value. All right, and then over here, the HC color will be the inverse of that, and it'll be a lovely shade of green. I think that should work. And it's exactly inverted. It's always exactly inverted, no matter what I do. I'm a living embodiment of a USB connector. Flip it twice. All right, so now it thinks we're likely to be a center line. Now it thinks we're likely to be an edge line. Now it thinks we're likely to be this line. All right. And the confidence changes as I'm squiggling it around. Now this is in the vertical. Now to do this in the horizontal as well, do we add a horizontal, like could it be vertical in one dimension, horizontal in the other? I mean edge in one dimension, and so in other words, if I'm here on the vertical, it's definitely this, but on the horizontal, it'll be definitely the other one. So I'm guessing we need to bias between horizontal and vertical. So we have like a two-dimensional bias, right? So I don't think I'm going to redraw all of it now. Also, we don't really need the two lines. I think whichever is the closer line is always going to be the line we consider. Excuse me. I can't think of any circumstance where we'd ever consider the line that's more than half a cell unit away from us. From whatever, and I think the midpoint is as good a point to consider at this point, especially considering the midpoint changes as you're drawing the line. I think it's more important because I'm just thinking, you know, you could have missed it and you might want to correct, and you're gonna go back and, you know, redraw it or whatever. And I'd rather spend time doing some intelligent stuff like saying, hey, if one of the other type already exists in the area, then bias towards that. So bias, like make it hard to draw the two lines next to each other, make it easy to delete the existing line. Because to draw both lines in the single cell is going to be a very rare circumstance. To the point that no other tool has both of these, or, you know, PenPad doesn't have both of center and corner lines on the same tool. They're two distinct tools actually there. All right, so I think now what I'm gonna do is I was gonna say I'm gonna look only at edge or only at center lines, but I think I still need to consider the edge center bias on the vertical and on the horizon, on the vertical and on the CE bias R. Okay, so if we do this, and then we'll do the C bias C on C, and then can we just mix them together, I guess? I mean, they could cancel each other out, but then, you know, then we know we have a conflicty thing going on. So the conflicting points will be here on the diagonal between the 2 points, right? So if I go here, yeah, this is exactly where the horizontal and the vertical basically swap places, right? The center of the edge lines, because, you know, on the vertical we're definitely on the center line, on the horizontal we're definitely on the edge line. So it doesn't matter if we're vertical or horizontal at this point. So the row bias is towards, the row bias here is towards a, yeah, and then the direction of the line tells us which bias we care about. Or do we want to consider both? No, I don't think so. I don't think we need to consider both, right? So we just need to find out if it's vertical or horizontal by taking the delta R and delta dr, or the VH basically. Where are we calculating the VH? This we go. Here we go. Oops. So mid RC, yeah, da, da, da. And we want to output VHRC. And that should be our current verticality. 1, -1, -1, -1, -1, 0, 0. Okay. So whichever one is the 0, we don't want to consider basically. Or do we want to mix them, right? To say, hey, what's the actual angle here? I mean, you know, we could. Basically, the vector we calculated earlier. So if we do let delta RC equals RC dot sub start RC and RC. So that should be the delta row column. And I mean, we could do a linear ratio, I guess. I think a linear ratio will work between the vertical and the horizontal. Okay, do we have an RC apps? Doesn't look like it. So let RC ratio equals math.apps delta RC.R R. And 1 second, the maximum here will be .8. The maximum will be whatever this is, min-dist, right? So if I divide this by min-dist, I'll do the same thing. No, it's a ratio. We shouldn't have to divide anything by anything, right? C. We don't care if it's positive or negative. Right, let's see. RC ratio. Wait, how? Let me think. What am I doing wrong here? I want a value between 1 and 0. But obviously, if I divide, 0.1 by 0.8, that's a ratio of 1 to 8, not a ratio of 1 to 0. Do I really have to do an arctangent here? All right, I was trying to skip something. We have a delta R, we have a delta C. Wait a second. If I calculate the ratio between two values, and I know that the two values are between 1 and 0 each, and I want a ratio between 1 and 0, I can't divide one by the other. Yeah, I don't think I can do a linear ratio here. So that was a barking up the wrong tree. So that should give us a value from negative half pi to positive half pi or whatever. We can maybe silence these guys. 1.3, 1.5. Okay. Is it always positive? I think it's always positive. Perfect. Math times 2 divided by math.pi. So that should give us a 0 to 1 between the two angles along a sine curve, right? So RC ratio is 0.9, now it's 0, 0.9, 0. Okay. No, it's not going to be perfectly linear. Well, it's linear with angle, right? Okay. So that's our horizontal vertical view. All right, we have an RC ratio. And now we're gonna, sorry about that. We're going to use that ratio. YouTube is complaining about not getting enough video. Uh-oh. Is my internet connection struggling? It very much looks like it. Twitch is complaining as well. Uh-oh. I don't know if I'm connected right now, to be honest. Everything seems to be in the red. One second. OBS, 5.5% dropped frames. That's not good. Yeah, Twitch just dropped into red. Alright, I think Twitch is back. YouTube is not actually showing me anything. Stream health, error. YouTube is not receiving user and smooth streaming. Such user experience buffering. Second. I'm running a speed test in the middle of a stream. No idea what's going on. Yeah, even the speed test is not connecting. This doesn't look good. Ah, okay. Is it back? Are we back? Nope, errors again. Yeah, it's not the local connect. I don't know if YouTube hasn't already ended the stream. All right, I think I'm reconnected now. How's this? Is this better? The quality is at 240p for me, but I think it's running now. All right, are we? Yeah, that sucks. So it looks like the restream servers were struggling for some reason. All right, well, I posted a message to the Twitch chat. It just means I can't stream to both at the same time. I have to look into that if I could directly stream to two different intake servers. All right, well, I got more important things to do. So I want to draw just one set of lines right now, just edge lines. So let's do an edge line, and I only care about the closest point, right? So yeah, we only care about one point at this stage. A point that line passes through. We're not caring about where the line starts and stops. All right. So and I believe edge line. So the closest edge line will be the one where I'm adding 0.5. And we're just gonna make this for now. For now, we're just gonna do this. Oop. Right? And the vertical line will basically look very similar because it's gonna use the same point, but it's gonna be basically this, I believe. So that's basically just going to be a blue cross. HE. Oops. Actually, this is going to be a VE line. VE line. No, that's wrong. Okay. Yeah, it's offset by 0.5. Yeah, this should definitely be on the right side. So I guess I have to do this. And this should also be here. So this is actually +1 here. Yeah, this area should definitely be this line. What am I doing here? I'm not... Jeez. I need to do this. And then it probably was 0.5 in both dimensions. Yeah. So depending on which quadrant of the cell we're in, okay. And then the bias tells us, well, we have two biases now. We have a center edge bias and we have a row column bias. And the row column bias is the RC ratio. And I think, yeah, this is, we can call this a bias as well. This one does not care about, you know. So, sorry, it doesn't care about which kind of line we're drawing, right? And we're just gonna put these in here for sake of convenience. And I'm just gonna blindly run it and then flip it if I get it wrong. Yeah, we got it wrong, of course. Okay, so that should tell us amongst... Oop, what was the error? Can read properties of null. Debug line 51. 51. Reading pen child cannot read properties of... I think I was dragging while puzzle hadn't loaded yet or something. Okay. So here it thinks it's a vertical line, it thinks it's a horizontal line. All right. Now we'll do the same thing for the center lines. And since this is no longer horizontal, it's just edge line. And this is going to be simply center line. edge horizontal, edge vertical, center horizontal, center vertical. Center line, right. And now we're gonna do it the other way around. So we're gonna, are we adding half here as well? Or do we round it first? I think we're rounding it and then we're adding it back in. I think. Or then we're subtracting it back out. Something like that. And this will be the green one. We're gonna hide these for a moment. We're adding, and we're rounding, and then we're adding back. Okay, these are definitely center lines. So what's happening here? Okay, so we're adding 0.5 from this point to here, and we're flooring it. Now we want to add 1. Then we want to floor it. And then we want to subtract. I think that's what we want to do. I really should rename these, but I'm using them elsewhere, so I can't change it now. Okay. And it does the same vertical horizontal biasing. Okay. So both of these crosses should now work in tandem as indicators. And now we just have to figure out if what they're showing us makes sense. So here it thinks we should be an edge line. Here it thinks we should be an edge, but now it thinks it's more like a center line. So, but here, to help us decide, we obviously now have the CE bias, which we're not using yet. So the CE bias is what's going to determine the stroke width. So it's going to be 2 plus 20 times CE bias. And here the opposite, and then we'll do the same spiel again of reversing it if I get it wrong, which undoubtedly I will. And that should finally tell us which is the line we actually want to do. So 1 second. The width is according. So the width tells us according to the angle. No, not according to the angle. The center bias. So the opacity is the verticality versus horizontality. Okay, so that looks fine. The horizontal is mostly opaque and the vertical is mostly transparent. But here it thinks we should be on the green line, which doesn't make a lot of sense to me because we're definitely closer to this blue line. But it could simply be no. What? Right, here it clearly knows we're drawing an edge line. Okay, now if I draw from here, see that should definitely be the blue line. The blue line should be much thicker than the green line. So the CE bias here is failing me. I am calculating that from the merged RC biases. So let's have a look here. The row column bias here is towards column. So yes, we are doing a horizontal line. No, wait a second. What am I doing here? CE bias R. One second, my brain. I'm missing something here because this and this completely ignore I don't think this... Wait a second, what are these supposed to tell me? Because they're not telling us edge versus center. These are both edge biases. I'm an idiot. So we're only looking at center bias right now. Yeah, so sorry, my brain. No, wait a second. CE, that's center and edge. But I'm only taking one of those things into consideration here. My brain. My poor brain. I mean, it should be trivial, right? The RC bias should clearly tell us that we're drawing a horizontal or vertical line. Right? Right, like even if I do something screwy, like drawing it across the center diagonally like this, if the angle is more like this, we want horizontal. If it's more like this, is vertical, right? So the moment we've decided vertical or horizontal, the only thing left to decide then is center line or edge line. Right. So first of all, this thing, we're going to move it up here. Then these, we don't actually use these. So we have an RC bias. We don't actually care about all of this at the moment. So if RC bias is less than 0.5, so equals 0.5, do this, else do this. And we're basically simply drawing vertical or horizontal, and we want to draw both edge and center because we haven't really decided yet, right? So we have edge line and center line, right? So now we want to draw, if it's less than this, we're just going to do this for now. Right? And the center line. Yeah, both of them horizontal. If that works, we'll do both of them vertical as well. Step 1. Yeah, well, it's not making sense to me so far. Delta RC. Where am I using it? Where am I using Delta RC? 272. Ah, sorry. Okay. So that gets us the two lines at the right relative positioning around the wait a second, what? Ah, and that's obviously vertical. That's horizontal, right? And then and maybe I can just hide them somehow. So we'll just do R0 C0 times 2. Get the lines out of the way. Closest thing to deleting lines I have here. So center horizontal and edge horizontal lines. And we'll just delete them when we're going vertical. All right. And then we'll do the reverse with the vertical lines here. And then these will draw vertical lines down here. So EV, CV, And then the V lines have these things reversed, right? So that's -3, that's 0, and that's -3 and 0. I'm trying to break down the decisions so I don't do them all at once. And then I should probably draw this out on a piece of paper, right? All right. And now I think it becomes clear that the only deciding factor really is which of the two lines is our midpoint closest to, right? That's the line we want to draw. I don't think... okay, well, the other deciding factor might be that the midpoint of the relevant line, because we have a center line from here to here, right? So this particular line might actually not make a good center line because the center line midpoint would be here while the edge line midpoint would be here. So let's actually try to draw not a oversized line, but the closest line to the midpoint that is relevant. So I guess from -1 to 0, then here -1 to 0. Yeah, you see, this doesn't make sense. This should be on this side still. Okay, so that tells me that our E-line point is not in the right spot. Okay, let's mark it similar to what we did with the center point. So our E-line here, and let's not make it quite so bombastic here. And we'll do it. Oh, and these should be, you know, semi-transparent. We'll use this color, but less transparent. And this would be E-line. So just drawing a point, because I have a feeling that those aren't on one of the corners. Yeah. So that doesn't give us the center line, right? We kind of want the center line of that. Yeah, because... yeah, well... if we're adding 0.5, I think that would be more appropriate, right? E-line. If we're adding... one sec, let me think. We want this to be there. Yeah, because if we... let's say if we're always going to the right, we don't want this point, we want this point. So... yeah, we want to actually calculate the center point of these lines. And then we'll know which, yeah, okay. All right. Which means, because that gives us the closest corner, but we actually don't want the closest corner, we want the closest edge. Which is a little trickier. Brain, come on, brain. You can do this. I'm here. This whole half. The thing is, now it matters if we're horizontal or vertical, right? But that's okay, because we know if we're horizontal or vertical, right? So let's do these one at a time again. And we only need... no, we do need both. Right? And now we know we are in horizontal land. And here we're in vertical land. Oh man, my brain. My poor little brain. Horizontal land, and we need this. So in horizontal land in the column, we need to add a half column thingy back in after. So if we do this, and yeah, this is a total mess, and I'll clean it all up, but I first need to get the formula to work. But only in the column. So we have that midpoint. No, it should go to this one. So this still floors to this one. So maybe we don't actually want to add 0.5 here. Sorry. Maybe we want to add 0 to the column. So the column is correct here. Okay. And then the line goes from negative 0.5 to plus 0.5, with the blue dot being the center of that line. Yeah. That's it. Okay. And basically for the other line, we want to do more or less the same thing. I'm not entirely certain what that means. Let's see. We probably have the exact same problem. Yep. And if I go over that line, it jumps to over there. So I want to add center line, horizontal. We're adding 1 before we're rounding it. And then afterwards, we're subtracting 0.5. So we end up there. But I don't actually want to subtract 0.5. I want to stay there. But I don't want to jump over there. So this should be 0.5, I think. Yes. And then we need to go minus 0.5 and plus 0.5. To be honest, it feels like this is something I actually implemented because I remember marking them by their center points. And now I think it'll start feeling right-er. Yeah, now it feels like the line that we're looking for makes more sense. So basically, the midpoint, whichever the closest midpoint is of the edge, that's the closest line. And now we just do the same thing for horizontality, I guess. So, vertical. So, is it the same points though? Or are the points... I think the points are reversed now. So for vertical line... And blue is edge line. So it should be this one. So now... the 2 points are actually reversed. I believe. So if I draw these 2 points, I think they'll be exactly in the opposite positions of what they should be. So blue here should be the center line, but blue is actually the edge line. And green is the correct edge line. This one versus this one versus this one versus this one. Okay. So these are actually completely reversed. And that's exactly why I couldn't get it to work right in both directions, because I was always using the wrong format. Okay. We'll We'll do the deleting at the top so we don't forget it. All right. And then I think we can just draw the line. Not sure if that actually will work, to be honest. Yeah. So it's minus 0.5, 0. No, wait. We're now drawing EV, so the vertical line. And the vertical line needs to be... yeah, different rows, not different columns. And then we can rebias it, re-enable the biases, and then I think we're there. Right. I'm just going to reuse this. Whoops. This now. So this is the EH line. No, this is the CV line. The center line vertical. And the center line vertical also is on rows versus columns, right? And then the color is this. So, oh, nope. C line. Yeah, I think this is what we want. Only thing here is like I can go from here to here, and it's actually giving me this line as if I drag from here to here. But it's closer to this than a line from here to here, right? And these are the only options. So obviously at this stage, the more likely line is the center line, and that's what the bias should reveal now. So we've now dealt with the row column bias. Now the question is the distance between this point and this point and this enough to bias edge versus center line? And do I need to do a distance calculation here, or is there some other proxy I can use for that bias? If I rename these to E dot, E line, E dot, C dot, C dot, and then I can reuse C line here, and then I don't need to delete the other line, and I'm not using it. E line, get rid of these. And I don't think there's ever a position where one line makes more sense in vertical, and the other one would make more sense in a horizontal, because the angle of this line makes all the difference, right? Like if I draw from here to here, it's horizontal if it's more horizontal, and it'll be vertical if it's more vertical. All right, let's just bias it via distance for now. So the maximum distance we can ever have is, I think, is 0.5. So let C dist equals, and we're between mid RC and, let's kind of do, let's call this E line RC. Wait, before I do this, these two calculations are because didn't I just say that these two are the same calculations, just reversed? So if I do this, are these two the same as these two? Yes. So basically, this is let mid. So they're both midpoints, right? Let's call them mid A and mid B. And then here, that would be mid A. And this would be mid B. And then this would be the reverse. Mid B, mid A. And then the only difference in vertical or horizontal is the delta here. All right. So dist A, then we can reuse it on either side. And we have a dist B. I reversed the left of the operator already. The left of the operator. Uh-oh. I don't know what you're referring to. You reversed the left of the operator already. Not sure what you're referring to. E line equals mid B. Ah. Yeah, you're absolutely right. But wait a second. Why does it look correct? Why does it look correct? Why does it look correct? It should not be correct. It should not be correct. But this looks correct. I'm going crazy. You are right, but now I'm wondering, does this somehow not matter at all? It still looks correct. Hey, Anshuman, how are you doing? This, it still looks correct. I'm going crazy. These are different values, right? They're not the same thing, somehow, magically. No, they're obviously a different one because I'm drawing them there. That's just switching horizontal and vertical, right? Is it switching colors, maybe? No, blue is center and green is edge. Green is always center. OBS got disconnected again. What the heck is going on today? I don't know why these don't seem to matter. I guess I can look at them. But this is a bit odd. Yeah, like they're clearly different places. What the hell? So I'm drawing blue on E and blue on E in either one. Hey, Shelby Lee. Yeah, I don't know what's going on. It's breaking my head a little, but it means that we're not swapping anything. Somehow. We just have two midpoints. Basically, the two closest edges. One is used for center lines and one is for center to center and edge to edge. Okay. I don't know now. I thought mid A and mid B. Oh, wait a second. Yeah, no, they are the same because the lines can be defined by their midpoints, right? And if the line we're supposed to draw is the one whose midpoint is the closest, it's always the same midpoint. This is always an edge midpoint. And it was a problem before because I was using corners, like the endpoints of the line, and that was complicating things. But now because we're doing midpoints, there's 4 midpoints on each cell, 4 edge midpoints. And I need the 2 closest ones, one of which will be the center line and one will be the edge line. And they're the different line. So they should still be switched, right? Because, oh no, I'm an idiot. The green does switch from center to, so here green is center. Here and here green is edge line. Okay, so it doesn't switch the colors, right? So it's just it's the colors that we need to switch, basically. So here, this is not the edge line. Yeah. Okay. All right. So we do need to switch them. It's just labeling and colors and such. We're drawing 2 lines. We're drawing 2 lines in the same 2 shapes on the same 2 points, but with reversed identities, right? And I'm not going to factor that identity back in because I have a feeling that identity is simply going to factor out later on. So, because right now we have 2 distances, A and B. And that should tell us which point we care about to draw on. So and the maximum distance from both is, how do we lerp this, basically? Right, so we have the midpoint, because the midpoint could be here in the center. And then the maximum distance would be 0.5 from both of these. And so basically, if you think about a diagonal line perpendicular to these points, we're looking at the distance from that line, and that's our percentage. If I want a smooth 1 to 0 thingamajig, which would involve dot products and all this yada yada yada. Or the other way around, right? We can do a line between these 2 midpoints, and then we can do distance to line on those 2 midpoints, right? Distance to line. I think we have a helper function for that somewhere. We definitely were using that the other day. Distance to line. Here we go. I'm not afraid of copying these kind of simple functions quickly. Yeah, so if we calculate distance to line, the point being our midpoint, so mid rc.r, mid rc.c. This is going to be a bit painful because I'm switching from RC format to array format. And the 2 points are basically mid A, mid B. 1 second, I'm getting emails. I'm wondering if that's related to the connection issues. Nope, it's just a bunch of spam from Google and various places. And basically mid B. So what I'm doing now is I'm taking a line between the blue and the green point, and I'm calculating the distance to that line from the That's not the, we need the 90 degree swapped line. Damn it. We don't need the distance from that line. We need the distance along that line. So swapperoonie, right? Dot product, right? Dot product. That flips the angle of the line by 90 degrees, right? Ah. What's the dot product? Give me a dot product. So the rubber takes two equal length sequence of numbers, coordinate vectors return a single number. You can, no. Rotate line 90 degrees. What's the...
Say you have the equation y equals 2.
Yeah, I don't need the mathematical thingy magic. I need the...
We know that the y...
Well, because that doesn't give me a smooth, you know, because the distances, I have a 2D space that I can move around in, right? Because I have two distances, and they can add up to 1, but they can also add up to less than that, right? Because the minimum distance, like let's say if it was in the middle here, the minimum distance is, or the length of that line is square root of 2. So what I need is, I need the line, not this line, I need, imagine the red line, and the distance towards that red line, where this should be 0.5, and this should be, you know, and wherever this point is, and this point is, you know. So basically all I need to do is calculate these 2 points, right? So it's the corner between these two and the center point. And I think that means I can just swap the R and C between the two. So I can do this and this. Let D equal. And then if I have D here, meh. Again, just rough prototyping. So D, so if we're here, D is 0.6. And if we're here, D is 0.01. 0.68. And if we go on the other side, D becomes small. So we go from here, 0.04 to roughly here. So 0.66. So that's, I think that's the square root of 0.5 or something. Yeah, it's probably this, right? And the distance to the line, doesn't it go from positive to negative? 1 second, we can actually draw that line, right? We have the power. So if I draw a line between these 2 points, red, green, whatever, 0.8, and the 2 points are these two. So back into RC land. And this one. All right. So that's the line, the blue line. No. Mid A, RC, mid B, RC, RC, CR. Wait, what? How is this a vertical line? Mid A, row column, mid B, column row. Ah, wait a second, I'm an idiot. What are these mid A, mid Bs? Ah, no, these are the ones where we put the points, yeah. So E line is mid B. No, wait a sec. We need to swap both of them. Otherwise we're going to be aligned on one of them. Oh, okay. Almost. Almost. It's sometimes true. Damn it. It's sometimes true. I think I need to do this. Does anybody remember this from algebra or geometry or whichever thing that deals with that stuff? The thing is, it's also the sides of them are flipping, right? Come on, my brain. I mean, I can figure it out. It's just I'd have to take horizontality and verticality into consideration to use this, because I know that, you know, I'm going to go down, whatever. And it's got to be towards this one. So probably what I have to do is, if it's smaller and bigger, flip from one to the other. I want to rotate. I have 2 points, and I want to have a line that's 90 degrees rotated. Perpendicular line, right? Calculate perpendicular line. I don't need an equation. I need code. I need an algorithm. Ugh, you do it. I have to do... I thought I didn't have to use sine and cosine. That kind of sucks. So let's draw a line from A to B as a reference. That's our AB line. And I don't know what's going on now. All right. R sine A cx cy cosine A. What is R and A? What is R and A? Oh, does he have some sort of R times? Does he convert? Is he calculate the angle and stuff first? Oh, he does calculate the angle. Well, I know I can get the angle and then rotate the angle. That's kind of like cheating. See you, Ben. Thanks for stopping by. Not the length. I need a line perpendicular to it. I need its normal. I guess I'll just have to bite the bullet, calculate the angle. But isn't it a dot product or something like that? Normal vector. Like, it's often easy to find the maths, but then to turn that into simple code, which is often simpler than the maths, it's often very hard. No, not a normalized vector. God damn it. Not normalized. Perpendicular. Give me a freaking perpendicular vector. Come on. I've done it so many times. I've built a million vector libraries to do it. I don't want to redo it. I just want to use some code quickly. Direction. Close point to point. Subvector. Direction multiply scalar. Nope. 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 Yeah, it's basically the expanded version of that simple matrix calculation, right? Ugh. Let me think. Or do I have to do the sine cosine thing? Because I believe the angles they eliminate out. Because both lines are in the same angle, just rotated by pi, right? So if you calculate the angle first and then go through all the maths, afterwards you end up without the angle in it. Yeah, that's what I was trying to do. Swap the x and y coordinate. Ah, wait a second. But I wasn't putting it into relative format first. So our vector is rc.sub mid a or mid b mid a, and then simply swap the x and y components and negate the new y component. So this gives us a zero-based vector, of which I then can swap the components and then add mid a again back in. So this gives us 0. Yeah, so it's always whatever, right? Then we can swap them. So let VRC equals this, then VRC dot R equals I'm too lazy to do... I'm being an idiot, but anyway. Same thing. Oh my god. I hope I can get rid of all of this code afterwards, so nobody can see my shame. Alright, so that should give us the reversed vector. And then we should just be able to add mid a back in as a starting offset. All right, get rid of that, and rc.add mid a. And that should give us... Ah, no, wait. The problem is, right, if we're flipping 90 degrees, we don't want to be attached to this anymore. But we would be. So if we now draw a line from, let's say, mid A to VRC, like this, with slightly different values so we can distinguish them, maybe a different name so it doesn't override the line. So the green line has the right angle now, but it doesn't have the right position. It's 90 degrees rotated relative to this point, but we actually wanted 90 degrees rotated relative to its center. And to get the center, we have to take half of it This rotates the direction. Yeah, so we can get the center by... let AB RC equals... Let's do this first. Before I blow away the rest of my little brain. So we have this, right? That's this line. Now if we flip it, we want to take half of it and add it back into mid A. Right? Right, bear with me. This is gonna be a tiny little journey, right? So if we start from mid A as a starting point. rc.mul scalar. We add half of this in, and that should give us the midpoint. And then right now, from there, obviously, that's the wrong direction, right? But as you can see, the green line starts from the midpoint of the line now. Okay. Now we take half of this and subtract it from that. Let mid 2 equals this. So now we can do mid 2. We're going to add half of this into that. And we're going to, subtract half of it. VRC is... no. Yeah. Because we added it all back together, right? Haha! Okay, and now we can calculate distance. Ah, man. So the distance are these points, right? Let xrc equals this. I just want to get the result right now. All of this, I'm gonna clean it up. All of it is basically unnecessary. But, sometimes you gotta just get on with it. And, these are our start and end points. And now we should have a distance along this line, which corresponds to our closeness relative to the blue dot, where here, I don't even know what it's outputting right now. And forget about these. And this comma is gonna ruin my day. So, 0.3. Now if I go towards the blue point, 0.16. 0.14. Wait a second. Let's make this red. Red is the line, the bright red line, along from which we're calculating the distance of the midpoint. So as we're getting towards blue, the distance should reach this, which is square root of 0.5. No, that's 0.7 math. 0.25? 0.5? I think it's 0.5 times that. So 3.5 should be our... No, it's not. The distance to the red line, that's what we're calculating, right? No, we're not, because I swapped the R and C over here. in a vain attempt to roughly remember how I used to do this stuff. So we're going from the green point at around 0.3 to the center, which is around 0, and then we're going to the other side, which should get us all the way out to almost 0.3 again. 0.3 something, right? And square root of... So I'm guessing 3.5 would be the maximum value. Yeah, so I'm pretty sure it's going to be from here to here. The problem is it doesn't give us a direction. But if we shift the whole line to one of the points, so can we just always shift the line up? Okay. Well, we're calculating it relative to one of these guys, right? So... So the midpoint, we're going to the midpoint. We're adding 0.5. It would behoove us if this was relative to the center point. And the center point is mid... We don't know if it's mid A or mid B, actually. So if I do this relative to mid A instead... Yeah, that'll work. That'll always give us the distance to the green point, basically. So if I go start from here, this should be almost 0, and then over here it should be almost 0.7, whatever, right? Okay, all right. Now, can do D divided by... And now D should scale smoothly from 0 to 1, depending on how close we are to the one or to the other. And the one and the other is always blue and green, I believe. So it's always 0 for blue and 1 for green. Like, does it matter if we're vertical or horizontal? No, it doesn't. It doesn't care. Okay. So, the bias we are going to express via something. So, let's do this. 2 plus 20 times D. And then I'm suspecting down there, it'll be exactly the reverse because, you know, we've got that switcheroony going on. But I'm just going to stick it in there and see what happens, right? Man, it's almost there. Almost there now. Ah, we didn't invert it down here. It's just wrong in both ways. I'm gonna enable myself to draw the line a bit longer so I can move around more easily. It's not really a minimum distance, actually a maximum distance. All right, so We're now towards the blue. Now we're going towards the green. Towards the blue again, towards the green. Alright. I think that makes sense. So here the blue line makes sense. So the real trick is to see, okay, if I plan to draw a line, does it draw the line that I'm planning or that I'm trying to draw? Like, for example, I find it hard to do a straight horizontal line. My hand kind of goes down to the right. So it makes sense that it's a little accommodating in that sense. Okay. I think we have the algorithm now. It's just a convoluted, horrible, horrible mess at the moment. I think we can do without that. I think all of this is rubbish. We can do without that. I think this is rubbish as well. I think all of this is rubbish, but it's the functional part, so we're gonna use that as a reference. So these two are identical. All right. I think these two are identical too. Because the dots don't care about horizontal or vertical, obviously. There we go. All right. Since we're never actually swapping these, we can just swap these around. So this is just... all of these will be mid B. And all of these will be mid A. And I think we can get rid of these. Now we just got to simplify the hell out of this. I think so far they're making sense. It's sometimes hard to realize when they're not making sense, to be fair. All right. Now there's a bunch of these that I'm probably not even using. Like this distance, A and B. I'm not using that. RC bias, am I even using that anymore? I'm using it down there. So I'm gonna move it down there. Delta RC. I mean, probably don't need these extra variables here. Simplify, simplify, simplify. And we probably should call this something more understandable. All right. Now all of this stuff, mid 2, I'm not using that anymore, right? Turns out it served me just fine to measure versus the green dot here in this case. And that's exactly the thing. I'm drawing across the center, but because I'm drawing across the center, it makes more sense to be an edge line. While if I draw across this line, it makes more sense to be a center line, even if it's relatively close to the edge like this, because of where the end point and start point is. Yeah, I think, yeah, so when I do this, you know, before I think it would have snapped to an edge line, but where the line starts and ends clearly makes it a center to center line. At least clearly to me. How's the video quality, by the way? My preview is a bit all over the place. All right, so we need to be able to get you mean to be able to get rid of much more than this. So mid A, mid B. So these are the actual points, the blue and the green one. Can I simplify these? Oops, excuse me. I don't see how. Mid RC. Okay, so that's the black point. All right, fair enough. Yeah, RAB, RC, VRC. Mostly, the biggest problem here are the names. So I'm taking... So this is my rotated vector, right? This is the line or the vector from AB. This is the rotated vector, and then these are the offsets of the line that I'm calculating my distance relative to. So what am I doing in the end? I'm saying, give me progress along a line from A to B. Maybe I can wrap that all up into a singular function, right? And our line is from mid A to mid B. So const progress along line. And that gets us a point, P1 and P2. Then we can wrap all this mess up in there. Basically, all of this. It gives us progress along the line, but math of square 2. This is basically the distance from mid A to mid B, I believe. Let's find out. Dist rc.dist mid A, mid B. I think that distance is 0.5, right? Yeah, that's our math squared, whatever, right? So we can do let len equals dot dist p1, p2. And if we rename them to RC, there won't be any question about what the interface is for this function. All right. So let v1 equal RC2 minus RC1. Let VB equal the rotated version, which is this whole thing. Right. And then that's our new thing. Should this be from 0.5, negative 0.5, positive 0.5? No. This line should be... Wait a second. Mid A. The red line. Oh, wait, the red line. Yeah, the red line is just... The red line should be infinite, basically. Yeah, so this should really be infinite. So this should be like a huge number. Because we're looking at a distance from that line, right? No, this math doesn't care about the grid at all. Has nothing to do with the grid. That code is kind of completely independent from that. Yeah, the only thing I need to do is make sure that when you're drawing center lines, it clips them correctly. Because then you can get, you know, here it says, oh, this should be a center line, right? But you can draw a vertical line here like this, but that's elsewhere. Okay, so we need to get our two PA, PB, whatever. Running out of names here. So ERC, that's what we're calling the VB here. Yeah. And then we go mid A. Here is our original starting point. So that'll be RC1. And then it'll be this and divided by length. So this divided by length, and we're going to return that. And this would be our RC. And these would be PA, I believe, and PB. PB, right? And then we should be able to compare this D with the output from progress along line. Or, if I recall, mid RC, mid A, mid B. Right? And these should be the same values. So, boom. Look the same here. Look the same. All right. Let's do a little if D is not equal to this, dot error console, dot error mismatch. Yell! The numbers don't match up. So, ooh. But I think this will be within rounding error. Let's see how big the error is. Yeah, E -14, -15. So I think the only error comes because we're taking the full length. No, the length isn't actually the problem. I think there's an extra multiplication of square root in here. Because we've obviously simplified some steps, I want to say. I think this is the only step, actually. Yeah. But, whoa. Did it just kill the console? Did it just crash? Yeah, -16, -14. Super small. All right. So that means D, where are we using D? There, okay. We can replace all of this with this. Get rid of this. Get rid of this. Get rid of these. Get rid of this. Excuse me. Okay. Let's get this out of there. Then we have to give up on some of our debugging lines because we won't have all that information available anymore. Namely L01. Yeah. So mid A, mid B. Line. Right. And our final decision for which line we're drawing comes out of this. Now, currently I'm actually deciding a lot of this up here. So we're gonna have to see about that. All right. And RC. Okay, we don't need that anymore. Length. Dist, right. So we have that. Draw distance. Yeah. So ideally, we just have one function. We're stuffing in 2 points, and out comes which line it should be. In fact, out comes the new 2 center points, right? So we'll have a function here. Get center or edge, center edge line, and in go ARC BRC, and out come the new elements. Hey Mark, I'm trying to come up with a better way of deciding if the line should be vertical or horizontal and which segment should be drawn, because the way it is currently, it's basically impossible to use it properly on mobile. But I think I have it now. So all I'm doing is I'm wrapping up the algorithm in a nice function, right? So start RC is now ARC, and out end RC is input RC, and minimum distance, min dist will pass in as well. So now we get a length, we get an end RC, progress along a line. Then we'll do the decision making on the direction. So that would be start and end, A and B. And then we basically need to look at progress and direction. And for now, we can just return those. And we can look at what that looks like. So, start RC, input RC, min distance. And that should give us an area with 2 values. Second, got a message. Ah, it's 7 already. Oh gosh. All right. So that's a 0. That would be a 1. For the direction, right? And the first number is our... wait, what? Ah, so the first number is the bias center versus edge. And the second line is the bias vertical versus horizontal. Yeah, because it just restarts, right? And it decides on edge versus centerline mode once, and then then you're locked in that mode, right? So this is only really relevant for the first stroke, and then after that, it's actually quite easy to continue from there. Sorry, just gotta organize the dog. All right, so I think I can use those. The only problem is previously this function was only locking in the type of line. It wasn't locking in which of the 2 possibilities, right? Because if it's a center line and I'm here, well, it should, we'll see. So we have center line, We'll do... So the first one is... I think that kind of makes sense. It's a little magical. I'll be entirely honest. Because the CE bias depends on the direction bias, so it gets reversed depending on if you're horizontal or vertical, right? So, well, to be honest, I still want to do this stuff here. But I kind of need all these values, so returning doesn't quite do the trick just yet. Okay, so now we basically need to do these things and the line type. So if this line type equals undefined, do this, and should always be defined by the time we get to here. Okay, fair enough. So let's just do this here. Did I really just leave that behind? And then we can say, if here is smaller or equals to 0.5, so if we're doing horizontal lines, then if progress is 1, so this is a horizontal line, now progress is 1, which means we are doing an edge line, except it's exactly the opposite. Because progress is 0 right now, so we're doing this, now progress is 1. So if this then so one second. The first one is C, the second one is direction. So if direction is low and this is high, and if direction is low and this is low, so if direction is low and CE is low, then it's center horizontal. Right. Now, if it's like this, so CE high, then it's edge horizontal. And if it's this way, then we are, the direction is high and center edge is low, and then we're on edge vertical. And here, the final case, the direction, the second value is high and center edge is also high. And now we're on center vertical. Now, since we only care about center and edge and not vertical or horizontal, we basically need to differentiate these two. And basically this is and this is or. I'm sorry, this is and. So if these are all both on the same side of 0.5, then it's a center. So Can we calculate that into a signage thing? No, I'm not gonna worry about that. I'm just gonna put all of this into a if statement. If this or this, then we are center, else we are edge. And let's see. Center, edge, edge, center. Okay. And now, does it start drawing? All right. Let's hide all of this. Oh. So here we're back to the problem is that these functions aren't following this algorithm, right? So either we reuse the same algorithm here, because here it's basically doing its own calculation all over again, right? Sec C gets sec RC. So either we bring that in there, or we do something slightly different. So I'm wondering if most of the code in these two functions at centerline and if all of this stuff can be replaced, if there's a lot of similarities there. The other thing is that it won't let me change my mind once. That's a bit weird. One sec. Let's bring this up here. And we're gonna say equals CE. And then we can do let direction equals dir. And we can get rid of any of these things that are only designed for calculating prog and direction. So we should still get our marker lines. Okay. And the transparency should be this. Instead of green, maybe we make these even bigger. Red, greens. Instead of green, we'll make them whatever this is gonna be. Yellow, probably. Or like some sort of murky swamp color. It's almost as if the green... All right, let's get rid of that red grid. That's not doing us any good right now. We did not end up using that. Although it was a good reference. Yeah, you see, once we're locked in, it doesn't let you lock out again. So the trick is to make sure when we lock in, or we don't lock in too early, right? So right now I think we're locking in too early. Because I think the line type gets established instantly. Yeah, so now line type is center. And if I do this, it looks weird, right? Do these even, if line type isn't set, ref dist, next dist, target RC, previous RC, that's relative to what? The first point in the path. That goes from start position, so far so good. Should I maybe not be locking that in? We basically want to unlock the line type when we're below a certain distance. And the distance is calculated relative to progress along line. Center edge. Yeah, no, neither one of these tells us anything about the distance, right? I think this is the only thing that actually matters. So we probably want to put len in there as well. And then in the past, I did not unlock the edge versus cornery thing. This is probably... But I kind of always wanted to. So... Oops. If I do this, right? Line type edge, fair enough. And then the length. So I start from here and go to here. The length approaches 1. Here the length is less than whatever. The thing is, if we're below a certain length, can we back out of our path here? And does the length reset once we go further down the line? No, it doesn't. Yeah, that's the problem, right? Because it doesn't actually reset, even though maybe it should. So, The problem is it doesn't show the line until you get to here, but it's already locked in at that point. Or can we unlock it again? If we're... I think the problem is, right, if I go back like this and then our distance is short, but we have stuff in the path. So we need to look at the length of the current path. And if that length is 1 or 0, then we might be able to unlock it again. To unlock which kind of line we're drawing. So I'm going out of there and I go back. It's down to 1. If I go here and then here, it's down to... So at this point, I basically would like to be able to unlock it again. So if this dot current path got length smaller than or equals to 1 and len is smaller than 0.5. Right now I don't know what my visualization distance is. Previous distance, next distance. Prev RC, next RC. I mean, it's over half, so yeah, it's 0.5. Where was I? Then we reset this equals 0, and we're resetting the line type to undefined. And I think we should be as good as new. So at that point, console.warn reset. If this line is not equal to undefined, and because if it's undefined, then there's nothing to reset, right? Sec. It's hard to know if I've drawn somewhere. Oh. Can read properties. Reset. Current path length equals... Is there something else that's getting set up besides current path? Current path. Erase mode. Not sure where this error would be coming from. 161 354 354. Can read properties of undefined. Input RC. 161. Ref RC, target RC. Current path equals undefined. Equals undefined. So resetting the length to 0 was not enough. Yeah, you see, that's what I wanted. So now I can start from around here and go across, and it clearly should be a edge line. But if I go up here, it makes more sense to be a center line. If I go back into here, now it makes more sense to be a center line. So right now we're resetting. Yeah, that's what I wanted. Oops. Now I'm reset and I can do this. Okay. Now the question is, can I quickly do what I want to do without it doing something differently? Line type. The heck? Yeah, you see, why does it jump up there? But I guess that's just our internal debugging stuff, and there's a reason why we shouldn't be showing anything at that point, because there isn't enough information yet to orient that line. So if I go from center to center, that's where it seems to struggle. Gets a little fidgety. The thing is, our algorithm here is kicking in a little bit at the wrong time, I think. This is all about the erase mode. I have a feeling I can get rid of this somehow. Like, all this code is basically the same. It's just slightly different. Like, this part is exactly the same. Is equal RC path.pop. That's exactly the same. And probably at the time I was building it in such a way. So this whole part, I think this is completely identical, right? Path, push, next RC is equals next RC, path length -2, path length -2. If RC is equal, path.pop. If the length of the path is less than or equal to 1, we're adding to the path. If the next point is the same as the previous point, so we've just backed off by 1, we're popping it off the path, so that's when we're backing down the path, so we're going back. And otherwise we're pushing. So I should be able to wrap this into a little function, right? Add to path, next RC, path. And I don't think there's actually anything else I'm looking at here. And it could literally be this bit here. Like that. If is equal, we're popping, else we're pushing. Okay, and then I can just do this, add to path, next RC path. Oops. Instead of this stuff. And I think this function will work down there as well, and it's a very simple function. Yeah, it's gonna take a lot of like testing just to see how it feels. It's like one of those feel things which are really, really hard to test because there's no right or wrong. Okay, so now all that chunk gets replaced with add to path. And I'm guessing this next RC, this is all the same. Yeah, the pen tool was never really finished. Like, there's a... that was bad. Every now and then it does that, and then I don't know, like this. And then I do it again, and then it works. There's still a couple of edge cases that I don't like, where I would rather it would just not put the line. Yeah, my internet connection is struggling again. What's going on here? Dropped frames, 0.2%. Don't know what's going on here. Speaking of going on, I've been recording to this hard drive for a while. Make sure I'm not running out of space or something. All right. Next step is, I think this stuff is very similar. So that's the same. That's the same. So that's a bit different right now. But these three are the same, right? Seg cell. Okay. Seg RC. Now this is different. I'm wondering if this is wrong. I don't use a 0.25 anywhere else. I think this might have to be a 0.5. Ugh. And this one, prev next, that's all identical. Simplify this. I think mid RC, next RC, BHRC, vertical horizontal, next RC, mid RC. Are we recalculating everything from scratch here? I think this check we shouldn't have to do this anymore. Because we should be clipping correctly. And then we might be able to get rid of this. We still need the prop contains. Well, we kind of want to throw, really. We should never be in this position. Lazy programming on my part. Let's get rid of that other logging here. Yeah, you see, I'm trying to delete this line, and several times now it grabbed the wrong one. Like from here to here. To me, that like I'm starting here. It should not be making a line this early. Because it's not calculating the yeah. Because down here I changed to calculating the distance from the start point where the mouse moved. Here I think it's calculating the distance relative. Yeah, no, we need at least, we need the distance from target RC path. Let input dist equals c.dist target RC. I think we want that as well. Yeah, that's... I can't go into this thinking this is complete. I remember this was quite experimental and then I never went back to refine it. So I can't expect it to be refined. Just wouldn't be. To be honest, I think I should switch all of this stuff to using the new algorithm I've built. I mean, that's what I've built it, after all. What I built it for. So now I shouldn't be able to do that. But the problem is, it doesn't undo this line now. Why wouldn't it undo that line? See, now I'm back here, and I've got a line sitting here. And it didn't erase the line, that's the problem. Yeah, I don't think we're done with this yet. Because, you know, yes, I think we have a good algorithm now for finding the initial direction and the initial line type. I think that part is fine. But how to deal with the ongoing drawing operation, including erasing, especially when we're, you know, when we're around a very dodgy point down here. At least I can reset it, but you see, it's also like, in my mind, I'm thinking, oh, I go here, now I'm drawing from here to here. But in reality, the computer looks from here to here. It doesn't look at the whole path you've been drawing. It almost makes sense that if you haven't gotten a line yet, it actually resets the last position of the cursor every couple of seconds or something. Or it only remembers the last half unit of drawing. So if I draw like this, and now wait, and then draw this, it actually only looks at that last piece. Man, I'm sure there's like a thesis paper in the sort of usability aspects of what the brain does and what it expects to happen and how it feels, right? Like I want to draw a line from here to here. I did not expect this. But mathematically, that probably was closer to what was going to happen, right? But if I now put my debug lines back, I bet you that those would look actually relatively decent for that action. So if I go from here to here, yeah, you see? It wants to draw that horizontal. But because the other algorithm kicked in and got stuck in that mode now, yeah, it's definitely getting stuck in that mode too early. And I'm running out of time for today, so I don't think this is done yet. I was hoping to finish this off. In fact, I thought this would be a one-session thing. But I think it's important to make the pen tool a first-class tool on the mobile app as well, for it to feel right in touch. And hopefully it'll teach me stuff that I can then use for improving the editor as well. Even though this kind of control isn't really an issue with the editor, I think. Or maybe it should be. Yeah, you see? My algorithm, the new algorithm says, hey, the line should be where the blue line is. But the old system kind of gets stuck in that loop. Yeah, you see, because whoop, it shouldn't be making lines when it has so little information about them. Like I can make a loop just by circling that point, which in a way is nice because that might be a gesture you're doing quickly, you know. I can do the same thing by circling around the center. But if I'm moving slowly and then suddenly it goes and draws like a gajillion lines. Yeah, you see, it drew too many lines too quickly. Yeah. All right. I need to get on with the evening. I guess I'll revisit this tomorrow. I don't think I want to start something else while I'm still working on this. What's the dog doing? I think the dog just left the office. All right. GPS tracker on the dog. That's kind of nice. All right. Sorry I didn't get like a satisfying, hey, look, it's working smoothly now. Check it all out. I was really hoping for that, to be honest, because it's been going on a bit too long, even for my taste. And my brain is getting a little fried. But I think what we'll do tomorrow is we'll try to move the get center line algorithm. And I think one last step we can do is move this out of here. I think that should work. I don't think we're using anything else. Yeah. So maybe we'll do a to-do here. To-do. Convert add line functions to use get central line algo. Perhaps merge add line functions. I think that's it for now. Yeah. And then I need to get back to the editor because I need to move the editor. I want to get the editor to some sort of state that I can put it in front of people. There's a couple other things I need to do actually. I need to finish the letter tool so I can push the current test version into release because there's a whole bunch of little things that I've been doing. I mean, I think the last release on live has been ages ago. And that's not even talk about the release on SudokuPad, which is now, it doesn't have the edge tool. It does have the edge tool actually. It doesn't have the outer edge tool for slithered link puzzles, right? And there's a couple other things. Ooh. Yeah, that's just for my debug line. It's trying to draw a debug line out here and it's kind of screwing up. 110. Coming from 323. No, it's not. Three to 9, you mean? Why is it? Something here isn't working well. I suspect this is not getting calculated correctly. Oh. Where are their NANs? The heck? Mid A, mid RC, start RC, end RC. Something along these isn't working well. The first one exists, the end RC does not. We have a start RC. The end RC is calculated from end RC is calculated from start RC, input RC, min distance and length. So input RC doesn't have a value there? No, it does. Start, input, start, input, min distance length divided by length. So length is the only thing here that could cause an NAN. Length of 0. Oh. Start RC, input RC, draw dist. Isn't length and draw dist the same? Yeah, I actually kind of like draw this here. Yeah, no. Basically, if len 0 return. So I'm guessing outside the thing we can get a 0, 0 move vector. Because normally our did input move here shouldn't trigger. Interesting. All right. Now it makes me wonder why did input move triggers here. Because did input move looks at greater than calc distance previous input and double input distance is greater, not previous position. What? Special input position? Yeah, I need to revisit this sometime. How does length come to 0 though? Well, I mean, it could always come to 0. Like even if you move the mouse around, it could come back. There seems to be something about it being drawing on the edge that forces it to be 0, but it could always be 0. You can hit the same coordinates, right? So definitely not something we can afford to blow up on. I need to come up like with mini games to test usabilities. Like, hey, draw a line quickly along this path or something. All right, that's it. Enough wobbling. Let's call it a day. Thanks for hanging out, guys. Appreciate it. Sorry if it was a bit of a head scratcher today, but that's how the sausage is made. So, warts and all. In the meantime, thanks for hanging out. I appreciate it. Let me know on Discord and or at Sven at svencodes.com or on Twitter svencodes. Any suggestions you have for the app, any questions you have, anything you would like to see in the stream, etc. Obviously, there's patreon.com/svencodes as well. Subs on YouTube, etc. are appreciated. Appreciated for your company, very much so. And have a good evening. Take care.